All right, folks, good morning or afternoon, right? Happy Valentine's Day. Um, just a heads up today, right? We've got our sub, Miss Lewis is in. Today, what you're going to be doing for class is you're going to be watching this video, right? Complete the sub assignment. It's going to be called 7.5 sub assignment, and then complete the practice problems. Now, if you have any missing assignments, you can do those as well after completing the sub assignment. The sub assignment is what needs to be completed during class, right? Or by the end of the day. The homework assignments and all that, that's if you finish the sub assignments, you can work on those, or you should be working on those. Okay? So today our I can statement is to be able to use exponent rules with negative exponents. So the four that we've already used and that we've written down on page 17, we're going to use with this other rule. Okay? So the idea is we've got, let's say we have 10 to the negative fourth power. What does that mean? How do we make this positive, right, to the positive fourth power? And also, how do we work with a negative exponent? Okay? So let's just kind of look at what negative exponents mean for a second, okay? So you've got this table on page 36. Let's all turn to that page, okay? I want you to fill this out kind of as I do it. All right, so something you might notice, well, let's look at this table for a sec. Complete the table to explore what negative exponents mean. This is very important for understanding the negative exponent rule, all right? So let's start with something simple. We've got here 10 to the first power. Now, as a decimal or an evaluated expression, 10 to the first power is equal to 10. That's what we get. If we multiply 10 by itself just once, we end up with 10. That as a fraction is 10 to the over 1. Any whole number as a fraction is just itself over 1. Right, and then we move on to 10 squared. Well, 10 squared is 100. You'll notice it has two zeros now. Right? And as a fraction, that is 100 over 1. If we go here to 10 to the third, we notice there are three zeros before the decimal, and that is 1,000 over 1. Okay? So each time we increase the exponent, there's something happening to our number, right? Several things we can notice here. Oh, where's a pointer? I guess I don't have one. Okay, so let's use this. Right, first thing is, as we use this exponent, right, the exponent of 1, it tells us the number of zeros. Okay, now when we move up, multiply by another 10, we've got 10 squared now. The decimal has moved one space back. Okay, so let me show you all with this. Let's make our decimal a different color. Okay, so here, 10 to the first, the decimal is after 10. 10 to the second, it moves one to the right. 10 to the third, it moves 2 to the right. So it is 3 decimal places after the 1. Okay? Here, well, what equals 1? Well, if we look at this, we've got 3, 2, 1. What's next? 10 to the 0 power would be next, which means 10 to the negative 1 would be after that, which means 10 to the negative 2 would be after that, and 10 to the negative 3 would be after that. All right, so we're really just filling this out. Okay? So if we use these patterns that we've recognized up here, well, 10 to the 0 is 1. The decimal is right here. So as we go up, as our exponent increases, the decimal moves not this way, but this way. That's to the, I don't know. It's going this way. All right? So from 1 to 2, our decimal moves this way, right? To the right. Okay? So as we move down, our decimal is now going to start going to the left. So you can see with 1, the decimal is moved to the left, which means here the decimal is going to move, well, let's write 1 down. All right, let's do some zeros. Okay? If we're at 0, we're here. If we're at 10 to the negative first, our decimal moves here, 0.1. Okay? Now, if we move 2 decimal places, if we got to the negative second, we get 0.01, as you can see here. All right? And if we go one more space, we've got 0.001. Okay? So this exponent with the negatives shows us how many Well, how many zeros are going to be in front of the 1? Okay? If the exponent's positive, shows us how many zeros are behind the 1. All right? Now, if we write these as fractions, you're going to notice something really cool, okay? 0.1 is 1/10, and 0.01 is 1/100th, right? So, right around here, 10 to the 0, everything switches. It goes from being whole numbers, and when we go into into negative exponents, we get fractions, okay? And that is valid. That is what happens here, okay? So a negative exponent does what's called an inversion, all right? So 10 to the negative first power is equal to 1 over 10. 10 to the negative second power is equal to 1 over 100, or 1 over 10 to the second power. 10 to the negative third, if we look over here, is equal to 0.01, or 1/1000th, which is 1 over 10 to the third power. Okay? So pretty much here, if we have fractions being multiplied together, it means we have a negative exponent. All right? So for example, let's say we had 1/2 times 1/2 times 1/2. Okay? That's equivalent to 1/2 to the third power. It's also equivalent to 2 to the negative third power. All right? So on your homework and probably on the sub-activity, you will get a question like this: 1 over 10 times 1 over 10 times 1 over 10. And it'll ask you, okay, write this with a base of 10. I think the actual thing it asks you, let's see. I had the homework pulled up. It's a good homework. It's not too bad. All right? But it'll ask you to write this as 10 raised to a single exponent. So what that means is it wants you to write it with a base of 10. What exponent goes there? Okay? And you can't even see that. What exponent goes here? And as we know, right, 1/10 times 1/10 times 1/10 would be 10. Well, that's 3 times, but it's as a fraction. So it's negative 3. Okay? That is pretty much the exponent rule. So let's go to lesson 17. Okay? Or not lesson 17, but page 17. All right? This is going to be called the... Sorry, Nasser's yelling at me. Okay, this one's going to be called, I don't have a new color. I've got this color. Can y'all see that? That's going to be kind of, well, let's use it. All right? So this is called the negative exponent rule. And what this means, what this states, is that if we have 10 to the negative third, okay? I don't actually like this ink. I'm sorry. I'm going to switch this whole thing up right now. I can barely see this. My bad, folks. So like I said, it's negative. Come on, let's write this down. Negative exponent rule. And what that means is if we've got 10 to the negative third power, that is equivalent to 1/10 to the third power. Okay? You can write that like this as well. Okay? Those two things are the same. Now, when you've got an exponent, when you've got a negative exponent in a problem, you just treat it like a negative number. For example, if we were using the product rule, let's say we're doing 10 to the third times 10 to the negative fifth. All right? We still use the product rule. It says we have to add those things, so we will still add those numbers, right? 10 to the third plus negative 5. Now that's 10 to the negative second, okay? So we use those numbers within the other rules just like we would normally use negative numbers, okay? It's the same as if we were using the power rule, right? 10 to the third to the negative fifth. Well, what's 3 times negative 5? Remember, in the power rule, we have to multiply these, okay? Well, that would be 10 to the negative 15th, all right? So we can use these negative exponents just like any other exponents when we're applying a rule to it, okay? So with that, good luck. Go give that sub assignment a go. Finish that, and then be completing your homework assignment for tonight or any missing assignments. Okay. All right, you all have a fantastic rest of the day. Be great for Miss Lewis, and happy Valentine's Day. Go do something fun. All right. Bye.